Oddities, thank you for being with us on this Tuesday evening. Hope you're all well. Hope you've all had a fantastic week. Sorry to those of you in the UK that continue to have appalling weather. Let's hope you get some semblance of dryness and spring before too long. Anyway, what have we got for you this evening? Well, we thought we would do a bit of a countdown to the Artemis 2 launch by talking a bit about the moon and the history of lunar exploration. So this evening, Lou's going to be telling us a little bit about that. And also this evening, Dave is going to be announcing a sort of not exactly a competition, but a bit of fun regarding Messier objects. So we hope you'll stick with us for that. I am joined this evening by the usual suspects, Roger, Michael, Daz, Dave and Lou. How are you guys? Everybody okay?
We're lovely.
Good.
Fine, thank you.
Oh,
Good.
can't complain.
Good. Don't. So there we are. Just before we start, a big thank you to Gerard for his donation already this evening. Thank you very much, sir. Much appreciated as always. Who have we got here? Let's have a look. Ian's here. Hi, Ian. Pauline's here. Hi, Pauline. And a few others. So thank you for being here. And we'll get straight on with the show. Now, today, exactly 53 years ago, I went to my first ever rock concert. That would have been, if you do them, I'll do the maths for you. That would have been February the 17th, 1973. So here's a bit of a puzzler for you, a bit of fun. Which band did I go and see for my first rock concert? And I'll give you a clue. It's a legendary British rock band, founded in 1969, and they recently had a number 1 album. So
the Nolans?
No, it wasn't Shawaddy Waddy either. So anyway, any guesses? Which rock band did I go and see 53 years ago tonight for my first ever concert? Put them in the comments.
That recently had a number 1 album.
Yeah, exactly.
Oh, boy.
Because they are still going. And for any band that was founded in the late 60s still to be going and have a number 1 album, I think is quite an achievement.
I have an idea.
Oh, keep it to yourself. Let the viewers. So anybody got any clues? They're very well known in Britain. No, they are known in the States as well, but probably not so much. But there we are. All right. Well, we'll come back to that a bit later, and I'll tell you. So we're going to move straight on, and I think we will go over to Lou. We've got the usual features tonight, by the way. We've got Constellation of the Week. We've got Einstein of the Week, and we'll have some fun with that a bit later. So Lou, over to you.
Well, my goodness, it's been a long time. Moon's out there. It's bright every night. We know it's there, but we haven't cared too much about it for the last 50 years. So we're going to talk about that. Talk about why it's taken so long to get back to the moon. Mostly about the U.S. Lunar program, or lack thereof, as time went on. So we have a little presentation, and I can't tell you how much research went into this. I have not eaten or slept in days. We do this for you, our dear audience, so you don't have to.
There we are.
Let's see if I can share here a little bit.
By the way, while Lou's doing that, just a quick update on the Artemis 2 mission. As you may know, the landing, the launch to launch 4 astronauts around the moon is still scheduled for early March. They're still aiming for early March. They've had a few problems, as I think we were talking about last week. They were able to fix the problems in situ at the launch pad, and it was a problem with an umbilical leaking hydrogen. They fixed that, but now they have an additional problem with a problematic seal at the base of the rocket. They've tried throwing it fish and everything, but it won't go away. And they are working on that at the moment, but they're optimistic that Artemis 2 will launch 4 astronauts around the moon still in March. So we will obviously keep you posted about that.
Andy, just on a quick one on that. Also, they discovered during the full dress rehearsal, and then a second test afterwards, just to feel with the one of the fuel tanks, just to test the umbilical and the new seals.
Yeah.
Apparently, they've had to strip down one of the delivery pipes because the flow was insufficient. It was
Yes.
slow, and they think they're going to have to change a filter as well,
Yeah.
which is another problem that they've had.
Yes.
Oh, I'm getting adverts.
Yeah. Yes, they had a seal. They're not sure, but they strongly suspected of impeding the flow of fuel. Yeah, so they're going to have to replace that. Yeah, dodgy filter, as you say, that's not allowing fuel to get there properly. All right, so let's give Lou the floor.
Everybody can see my title slide here?
Yes, indeed.
Yep.
Excellent. Well, so it's been some 50 years or so since President Kennedy issued a bold challenge to land humans on the moon by the end of the 1960s, up until today, our current Artemis lunar program. America's lunar ambitions have shifted from a Cold War race to more or less a sustainable collaborative presence. Kennedy's Apollo program achieved the first landing in July of 1969, and I am old enough, sadly, to remember that day. I was in Miami Beach vacationing with my parents, and this was a promise that he made to land humans on the moon by the end of the decade. And it only took 9 years from the very first Mercury launch of Alan Shepard in 1961, and then Glenn followed in 1962. 9 years. I mean, that's remarkable. Our current Artemis program now aims to land the first woman and the first person of color on the moon as a beginning to a lunar base and a sustained lunar presence at the moon's south pole. But the journey from Apollo to Artemis has been rocky, to say the least, with many starts and stops, many twists and turns, driven by shifting political, geopolitical, and budget priorities. And this, dear audience, is the story of that journey. I don't know how many of you have listened to the speech that John Kennedy gave at Rice University in Houston, Texas, back in 1962, September 12th, 1962. But I listened to it in its entirety. We don't have time. It's an 18-minute speech, and so I'm not going to play all of it for you. But I listened to it in its entirety as I was putting this presentation together, and I was in tears. This was a remarkable speech. It was just so inspiring and made me wonder where all the great leaders have gone. But I'm going to play a little bit of it for you today. Again, this is September 12th, 1962, on a very hot day at Rice University in Houston, Texas. Kennedy is issuing a rather profound challenge to America that actually inspired a generation. Land a man on the moon, return him safely before the decade's end. This was not merely exploration, but it was also a Cold War strategy. I'm going to start this, and I'm going to move it forward to maybe some of his most memorable remarks. So let's see if we can get this to happen.
The volume is a little low on this, so you may need to turn your volume up, folks.
Okay, so let's go to somewhere around here.
Never come again. But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too. It is for these reasons that I regard the decision last year to shift our efforts in space from low to high gear as among the most important decisions that will be made during my incumbency in the office of the presidency. In the last 24 hours, we have seen facilities now being created for the greatest and most complex exploration in man's history. We have felt the ground shake and the air shattered by the testing of a Saturn C-1 booster rocket, many times as powerful as the Atlas which launched John Glenn, generating power equivalent to 10,000 automobiles with their accelerator on the floor. We have seen the site where 5 F-1 rocket engines, each one as powerful as all 8 engines of the Saturn combined, will be clustered together to make the advanced Saturn missile, assembled in a new building to be built at Cape Canaveral, as tall as a 48-story structure, as wide as a city block, and as long as 2 lengths of this field. Within these last 19 months, at least 45 satellites have circled the Earth. Some 40 of them were made in the United States of America, and they were far more sophisticated and supplied far more knowledge to the people of the world than those of the Soviet Union. The Mariner spacecraft
Okay, I wanted to get that part in just to kind of emphasize, as I'm wiping the tears away from my eyes, that this was in fact the national will to go to the moon was based largely, and the congressional will was based largely on the goal of beating the Soviet Union to the moon. During that period of time, the NASA budget soared to nearly 4% of the federal budget, peaking at $5 billion annually in the mid-1960s. That was a much more, it's $5 billion doesn't mean as much anymore, but it meant a lot back then. This was really an unprecedented investment that enabled 6 successful lunar landings between 1969 and 1972. The funding was justified as essential for national security, technological supremacy, and inspiring American exceptionalism during an era of geopolitical. The excerpt, and I encourage you all. It's easy to find on the web. Listen to the entire speech. You'll be waving the American. I don't care if you're British. You'll be waving the American flag and shouting USA, USA. I mean, it's just. He was a great president. From 1969 through 1974, the Nixon administration to the Carter administration, the U.S. transitioned from actively conducting lunar landings to abandoning crewed lunar exploration entirely in favor of low Earth orbit missions. Originally planned through Apollo 20, they planned 20 Apollo missions originally. The final 3 missions, Apollo 18, 19, and 20, were canceled between 1970 and 72 to save roughly $42 million. That seems like I don't even bend over for less than $1 billion anymore. That's incredible. And to repurpose the hardware for the Skylab space station. I don't know how many of you remember Skylab, America's first space station. NASA leadership proposed building permanent lunar bases by the late 1970s and a crewed Mars mission by 1981. But Nixon rejected these, as he felt, grandiose plans as too expensive. So in January 1972, Nixon approved the Space Shuttle program, which intended to make space travel routine and less costly. Let's get this going here.
Oh, while you're doing that, just another factor, the reason why we stopped going back to the moon. Many people forget that in the early 1970s, 73, 74, there was a global oil crisis where the price of oil went through the roof, which meant that economies, especially the United States, had much less money to work with on things like spaceflight.
Absolutely. Absolutely. Yeah. And it's all a matter of priorities, right?
Yeah.
He's there for whatever you want to spend it on. You want to spend it on stupid things like humanity, that's fine. We don't care.
Exactly.
All right. So let me start this. The transition of the space station program from the Reagan to the Clinton administration marked a fundamental shift from Cold War era national symbol to a collaborative international partnership. During his 1984 State of the Union address, President Ronald Reagan directed NASA to develop a permanently occupied space station within a decade, and this space station was dubbed Space Station Freedom. The project was intended as a US-led laboratory for microgravity research, satellite repair, and as a staging base for deep space exploration. While primarily a US effort, Reagan invited allies, including Canada and Japan, and members of the European Space Agency, ESA, to participate, specifically excluding the Soviet Union. President Clinton expanded the ISS partnerships with Russia and other international allies, emphasizing peaceful post-war cooperation. You may remember the words détente. Of course, Reagan also said trust but verify. So I don't know. Let's see here. There we go. Okay. That program faced repeated redesigns due to ballooning costs, growing from an initial $8 billion in estimated funding to over $11 billion without any hardware being launched, and constant threats of cancellation by Congress, of course. But funding rationale of the station as an important post for scientific research as well as international diplomacy, and I might say international supremacy, including maintaining U.S. leadership in space infrastructure, won the day, and the latter, named ISS, received funding for its full development. So then there was the Space Exploration Initiative. This was a public policy initiative announced by President George Herbert Walker Bush on July 20th, 1989, the 20th anniversary of the Apollo 11 moon landing. Speaking on the steps of the National Air and Space Museum, Bush proposed a long-range commitment to space exploration with three primary goals: completion of the space station Freedom, the predecessor to the ISS, returning humans to the moon to stay, and ultimately sending a crewed mission to Mars. However, Bush's visionary exploration goals clashed with political and economic realities, so the Space Exploration Initiative largely stalled, illustrating that ambitious space programs require both presidential vision and sustained congressional support. On to Mars. I trust you all recognize this image here. I took it from the movie The Martian. I just thought it was a great picture. Previously, lunar exploration served two purposes. First, to learn to live on another world for an extended period of time, and with that knowledge, secondly, serve as a stepping stone and launch platform for future Mars missions. This is reasonable, but expensive, and kept any real plans for Mars exploration at bay. The Mars Direct strategy was a minimalist mission architecture designed to send humans to Mars using current or near-term technology, emphasizing living off the land to reduce costs and complexity. Proposed in 1990 by aerospace engineer Robert Zubrin and David Baker, it avoids the need for massive orbiting spaceports or futuristic propulsion by proposing in situ resource utilization, or what, if you're at NASA, you would just say ISRU, essentially using the materials and resources found on Mars to support human habitation. Mars Direct has 3 core mission phases. Strategy typically follows a 2-launch sequence every 26 months, and that's the synodic orbital periods. In other words, Earth and Mars come close together every 26 months in their orbits. The first phase would be an uncrewed pre-deployment mission. An automated Earth return vehicle, ERV, is launched and lands on Mars. It carries a chemical plant, a small nuclear reactor, and several tons of liquid hydrogen. The plant combines the hydrogen with Martian atmospheric carbon dioxide to produce methane, oxygen, and water. The ERV fully fuels itself for a return trip over approximately 10 to 13 months. So that's phase 1. Phase 2, the crewed mission, once the ERV confirms it is fully fueled, a second vehicle, the Mars Habitat Unit, or HAB, you'll recognize these terms from the movie if you saw it, is launched with a crew of 4. During the 6-month transit, artificial gravity is generated by tethering the HAB to spent rocket upper stage and rotating them. The HAB lands near the fueled ERV. The final phase is the surface operations and return. This is where the crew spends 1.5 years, approximately 500 days on the surface. That again is driven by the synodic orbital periods of Mars and Earth, conducting exploration using a pressurized rover fueled by the ISRU produced methane. At the end of the stay, the crew launches in the ERV for a 6-month trip back to Earth, leaving the HAB behind as a permanent asset for future explorers. So basically, lunar exploration here, the ultimate goal was to get to Mars, and that's how they would plan to do it. 2005 to 2010 saw a refocus of humans going back to the moon. The Constellation program was NASA's planned future human spaceflight program between 2005 and 2009, which aimed to develop a new crewed spacecraft called Orion and a pair of launchers, Ares 1 and Ares 5, to continue servicing the International Space Station and return to the moon. The major goals of the program, in which no crewed mission ever flew before its cancellation, were completion of the International Space Station and a return to the moon no later than 2020, with a crewed flight to the planet Mars as the ultimate goal. The program's logo reflected the 3 stages of the program: the Earth, the ISS, low Earth orbit, the moon, and finally Mars. Or as we often would say at NASA, Moon, Mars, and beyond. While the Mars goal also found expression in the name given to the program's booster rockets, Ares, the Greek equivalent of the Roman god of Mars. The technological aims of the program included the regaining of significant astronaut experience beyond low Earth orbit and the development of technologies necessary to enable sustained human presence on other planetary bodies. By 2009, a single uncrewed suborbital launch test, the Ares 1X, had been flown, with crewed missions anticipated to begin between 2014, when an uncrewed mission was indeed launched, and 2017 to 2019. On February 1st, 2010, President Obama announced that he intended to cancel the program with the U.S. 2011 fiscal year budget. A revised proposal in April confirmed that the Orion spacecraft would be retained for future missions beyond low Earth orbit, and the Ares launchers redeveloped into the Space Launch System, or SLS, as we know it today. However, the Constellation program itself was canceled, with low Earth orbit operations transferred to the Commercial Crew Development Program, which itself would not begin crewed launches until Crew Dragon demos in 2020. So you see, this is really It's kind of on again, off again in terms of our will to fly beyond low Earth orbit. During his presidency, Barack Obama shifted NASA's primary focus from government-owned hardware toward commercially leveraged deep space exploration, specifically targeting a human mission to Mars by the mid-1930s. This strategy relied heavily on NASA's transition to public-private partnerships, which we're seeing an awful lot of today, right? To manage low Earth orbit logistics. He also refocused NASA's exploration program away from the moon-focused Constellation program, citing high costs and budget concerns, in favor of a flexible path, or what was just generally called flex path. And that was really more of a guiding philosophy for space exploration, emphasizing incrementally greater and greater distances traveled from Earth and flexible destinations such as asteroids, Lagrange points, or even Martian moons. So it was more of a philosophy than a target. The approach emphasized developing the necessary technologies in cislunar space, in other words, the region between Earth and Moon, before attempting to land on other planets. Okay. This strategy, often associated with the Augustine Committee report, acts as a mortgage-style approach to exploration, breaking down expensive long-term missions into smaller, more manageable, and more affordable incremental steps. It was designed to leverage commercial innovation for routine orbital flights, and in 2015, Obama signed the Commercial Space Launch Competitiveness Act. This allowed U.S. companies to own resources that they would mine from asteroids and other celestial bodies, hopefully as a little motivation to get private sector going. In addition, operations for the International Space Station were extended through at least 2024 to provide a stable platform for commercial and scientific research. It's amazing we're in space at all. Okay.
Indeed.
2017 to the 2020s. The Artemis program was formally established under the Trump administration in his first term, 2017 to 2021, via the Space Policy Directive 1, to return humans to the moon. And in 2019, Vice President Mike Pence set an accelerated and later deemed wildly unrealistic goal of landing astronauts on the moon by 2024. And I remember that and kind of rolling my eyes. Formally, though, this was endorsed. Let me see, what do I want to say here? The program was formally endorsed in February of 2021, maintaining the core objectives of a lunar landing while adjusting the target date forward yet again to 2028. Okay, a little more realistic. Biden expanded the Artemis Accords to 56 signatory nations and reached a landmark agreement for a Japanese astronaut to become the first non-American to land on the moon. While Trump aimed for rapid lunar, then Mars exploration, Biden focused on a sustained, science-driven return to the moon. Currently, the program is pivoting toward a more private sector-heavy model. The 2026 budget, as we've seen recently, budget proposal suggests that ending Artemis as a government-led program after Artemis 3 mission, the first crewed landing. This plan involves transitioning away from the costly Space Launch System, rocket, and Orion capsule in favor of commercial alternatives like SpaceX Starship. Influenced by figures like Elon Musk, President Trump is pushing to cancel traditional NASA-led components, such as the SLS, the Orion, and the Gateway Lunar Orbiting Space Station, allowing Artemis 3 to reallocate funds toward commercial Moon Mars initiatives. So, let's see. Yeah, okay. As we know, the NASA budget for this year has been largely funded to within 1% of fiscal year 2025 budget. So then we don't seem to like to do anything without a competition. And here we have the Chinese space program and the reemergence of global competition. NASA's official position, maintained by Administrator Jared Isaacman, following the 2025 change in leadership, is that the United States remains on track to beat China back to the lunar surface. However, while NASA's timeline for a crewed landing currently targets mid-2027 to 2028, China's steady progress towards its 2030 goal has led many experts to warn that the U.S. lead is rapidly narrowing due to technical delays. Some officials emphasize that the U.S. is already flying crewed-capable hardware and that the Artemis Accords have built a global coalition for sustained presence that China can't really match. However, some former NASA officials, including Jim Bridenstine, have warned that unless U.S. commercial partners like SpaceX accelerate development, it is highly unlikely the U.S. will maintain its lead. And I was at a Maryland Space Business Roundtable luncheon a week ago where I heard Bridenstine say, in his words, that ship has sailed. He's a former NASA administrator, but in his best estimate, he believes we will not beat the Chinese back to the lunar surface. China recently completed critical tests of its lunar landing engines and is preparing for the Chang'e 7 robotic South Pole mission in August of 2026. And that's pretty much where we sit today. We have a launch of Artemis 2 planned for early to mid-March, we hope, which will send astronauts around the moon, but not to land. And then if it doesn't slip, 2027, 2028, a human landing on the moon. And we will have to see. So that is my presentation.
Thank you very much, Lou. Really interesting stuff. And especially you talked about China. Well, it is, of course, the Chinese New Year today. So Happy New Year to all our Chinese viewers. And China recently tested
the year of the horse.
Year of the horse, yes. China recently China recently tested a new vehicle, a new reusable rocket, for which they hope to compete with the likes of SpaceX. The test went very well. They were going to land it, like SpaceX do, on a barge in the middle of the ocean. Well, it didn't quite meet the barge. It landed off at the side of the barge, but it was a soft landing. It wasn't a crash, so that didn't quite work. But as a first test, it went remarkably well, and we're going to have a look at it right now, I hope. Here we are. There's no sound on this video. I've had to remove the music, unfortunately, for copyright reasons. Otherwise, we get done for copyright. But it's an amazing vehicle. They've come on so far, so fast, and this is the stage separation, and the capsule splashing down. This will be the manned capsule, which they hope will take them to the moon. And there's the soft landing in the ocean, not far from the barge, totally under control. So they've had a number of tests that have failed. So there we are. So well done, China. And we hope to see more advances from China again in the very near future. So there we are.
Thanks for that, Lou. There's quite a bit to unpack there, actually. Because you were talking about the speech from Mr. I can't remember the president. Kennedy. Sorry, is that It's the
we choose to go to the moon and do the other things.
Yeah, do the other things.
Not because they are easy. Okay, I'm going to continue here. So.
Yeah, because of course, at that time, NASA was only 3 years old. And they'd been asking for a big project and, pushing for more responsibility, more missions and things like that. And I think basically being told that, the speech saying that they're going to go to the moon in the decade and return safely took them a little bit by surprise. Because if I remember right, James Webb is quoted as saying, we got what we wished for. What do we do now?
Yeah, right.
When he come back, and of course von Braun was disappointed because he wanted to go further. He wanted to go to Mars. Lots of ambition there. So yeah, that was sort of like took them a little bit by surprise and all that. And they did look a bit hot and flustered there because they were all there with their hankies mopping their brows and things like that, thinking, "Oh dear, what's just happened?" But no, it's
one of the things that Kennedy said in his speech, if you listen to the whole thing, he was referring to the heat of the engines, I guess, of the Saturn V, being essentially equivalent to the sun. And then he followed with almost as hot as it is here as in Houston.
Yeah, just a little bit hotter.
Yeah. And of course, you did say the final missions were cancelled, but then, of course, as you said, they went on to form part of the actual rocket parts, went on to form
Skylab,
Skylab.
right? Yep.
And of course, one of the benefits of that, if I remember rightly, wasn't that where the first solar dedicated space telescope was mounted?
Yes.
I think that's right.
In
I think that's right.
In the Skylab.
Yeah.
And that's where they got the first images of anything of the sun
Wasn't
before, except from the ground.
Wasn't it called the Apollo telescope mount?
Yeah, ATM.
Something
Yes.
like that.
Yes.
Yeah. Something
Yeah.
like that. Yeah.
The ATM.
Yeah. And of course, then you finished off with the China issue. Well, of course, as you said, they're going to beat us to the moon. Looks like they're going to beat the USA to put a base on the moon. But also they look like they're going to be beating the US to Mars for a sample return. Of course, NASA.
It's pretty easy to do.
Yeah,
since
but that's
our
it's not a priority.
That's
anymore.
right. I mean, you've got the sample sat there.
Your mother can be it.
You got the sample sat there. Now they're not coming back. So there's a few disappointments there. But this is when, as you said, the USA had ambition. NASA really came into its own to actually achieve that within a decade, to get people on the moon and to get them home safely. Because it took them literally almost all of that decade to do it. Of course, you got to remember all the everything that went before, the Mercury and the Gemini rockets and things like that. And as it all slowly built up, and it wasn't without drama with Apollo 1 capsule fire, which was a disaster and held everything back for quite a while. But the US, you got to take your hat off to them. They did it. They absolutely did it. They were heroes, all of them.
9 years from no one has ever flown in space from our country to landing on the moon.
It's incredible.
Yeah.
Right.
Incredible.
Yeah.
It's incredible. And looking back, it was a time when the world was united, that everybody who had a television or could see a television somewhere watched it. The world was united behind those 3 astronauts. Differences between people were forgotten. It was something that humans as a species were doing. For the first time, humans were united in this great event. And of course, we were all optimistic that that feeling of unity among humans would last. And of course, it didn't. We just went back to killing each other. But
That's true.
But the sad thing about it is that when we do land on the moon again in a couple of years, there will not be that same unity. That people are too isolated from each other now, too factionized. We've got a lot of people claiming the first moon landings never happened, and there appear to be literally millions of those. I have to say, it seems to be mainly in the US, which is tragic, considering it's the country that put people on the moon. And I've no idea why so many people in the US believe it never happened, when it was their country's single greatest achievement and humans' single greatest achievement. There's probably a doctorate in that somewhere if you want to study that. But
seems like we should have sent a lunar landing denier on one of these missions.
No, that will be pointless, Lou. Even if you took these people to the moon, even if you took them in person to the Apollo landing sites, they would still say it was fake, that it was all a put-up job, all a conspiracy, because they're idiots, basically.
I think.
No, I mean just throw them. I mean just throw them out of this.
Well,
space
that's
concept.
yeah.
Yeah,
I didn't mean
yeah. So
And they could
it's-
look back and see the Earth isn't flat. Also, I mean, so we can take care of two of these things.
No, you're viewing it through a curved window. That's what makes it look. Well, that's what they always say when people say they've seen the curvature of the Earth from high-flying aircraft. Oh, it's because they got special curved windows to make it look as if the Earth is round. You cannot get through to these people. You cannot throw facts. They always have an explanation. Anyway, this is getting away from the point. The point was that I'm happy to have lived through that period, that brief period of human unity, where
That
we
was
saw
amazing.
ourselves as
Yeah.
human first and black and white and Christian and Muslim. All that was forgotten for just a brief period in history. And we were humans first. And I don't know what it would take for that ever to return, if it could ever return. Very sad. I don't want to appear too down about this because I'm greatly looking forward to Artemis and, supporting it greatly. But it was a time in history I don't think can be repeated in the social effect that it had on the planet.
Probably not. And the other thing to remember, what we were talking about is with China is those Chang'e missions, those Chang'e.
Yeah.
They've been amazingly successful. I mean, they haven't had a failure. They've landed, they put robotic things, they've landed on the far side of the moon. Just one after another, they've been successful. It's pretty scary. I mean, it's great for science. It's wonderful for science. I mean,
well, they waited until we had perfected all that.
Okay. Yeah, because that's why we perfected it, Lou. That's why we have a perfect launch record with all of our missions. So yeah. I mean, it's amazing what they've done, and
and of course we've got NASA's commercial payload program, which at the moment seems to consist of making spacecraft lay on their side on the moon, there are going to be big things going on the moon or around the moon in the next few years. Not just Artemis. Lots of countries have got plans. We've talked about this before, and there's going to be a lot of activity centered around the moon over the next few years, and we will keep you abreast of all of it.
Can I just say as well, the Apollo era was TV. Everything was all on TV. This time round, it'll be social media.
And there'll be a lot of AI generated stuff.
That's probably true. Also,
will that be a good thing, or will the youngsters understand it all? I don't know. Yeah.
We should respond to the comment that you just put up.
We will.
Ian. Right.
Yes. Well, technically, Ian, it's not possible because the Outer Space Treaty of 1967, that all of the spacefaring nations signed, specifically states no person, individual, or company is allowed, or nation is allowed to claim any of the moon as their own. So that's written into law. The law's never been tested, obviously, but there is an international agreement that no nation, no country, no company, no individual can claim any part of the moon as theirs. So let's hope that it doesn't have to get tested, but we will see.
Did China sign that?
I think they did actually. Yeah, I think I looked this up.
So.
China,
I'd have to go back and look.
China, the
see where
US, all signed.
Well, I think at that point, because the U.S. and the Soviet Union obviously were dominating, other countries did want to get that signed as well because they figured it would be the U.S. or the Soviet Union that would be the first ones to be claiming stuff. So I think everyone else was happy to be signatories to this and make sure that it was, just like Antarctica, really. Yeah, it was, international.
Yeah, absolutely. So there we are. Thank you very much for that, Lou. That was wonderful.
Yeah, very good.
We will be bringing you further presentations as we get closer to the launch of Artemis 2, which, as I said earlier, is Well, they're aiming for March. It was initially going to be the first week of March, but then just now saying March. So we will tell you some more about the moon and Artemis as we get closer to the event. And of course, we will be covering the launch of Artemis 2 live, whatever time of the day or night it happens. So you can watch it here with us here on Space Oddities. So so there we are. Okay, moving on. Let me just answer the question I posed at the beginning of the program. The rock group that I went to see 53 years ago tonight, it was a full moon as well. I remember it very clearly. The rock group that I went to see 53 years ago tonight at the Kursaal in Southend-on-Sea was Hawkwind.
Yeah. Barry got that right.
Yeah,
Derek
got that
Derek,
right.
sorry, Derek got that right.
Derek got that right. Well done, Derek. You got it. There's no prize, I'm afraid, but well done for working that out. Secondly, there's a lovely new picture which I'm just going to show you now. I hope I haven't shown you this one before, but even if I have, it's still worth looking at again. Just let me put this up on the screen. There's a new image of the European Extremely Large Telescope in Chile. And this is what it looks like.
Wow.
I want to go there.
And if you look at the vehicle towards the bottom, you get an idea of the size of the building. It's it's a cathedral of astronomy. And no, Derek, I'm afraid this time around you don't get a book. It's immense. This is the world's biggest telescope ever built, 39-meter segmented primary mirror, and expected to be fully operational in about 4 years. It may look as though it's mostly complete, but they haven't put the telescope in there yet. I
knew they forgot something.
Yeah, absolutely. I was just wondering actually how they're going to get it in there now.
Yeah,
they put the roof on. Perhaps it's open on the other side. So there we are. But I mean, isn't that an amazing building? It's just stunning.
The LSS2 will go online first, won't it?
Yeah, it is. It's already online.
Of course.
The Vera Rubin, as it's now known, has started its observing run, and we hope to have an update on that before too long. So there we are. Okay, so let's just remove this. And there was something else. Right, planetary scientists. Here's a question. Would one of you like to explain why in our solar system we have rocky planets nearer the sun and gas giants further away?
Well, the idea is that basically the sun, either in a T-Tauri stage or some early stage, kind of blew most of the volatiles out of the inner part of the solar system, and they ended up, being more prevalent in the outer part, and the gases and the ices formed what's out there now, and the rocky stuff stayed in and formed the terrestrial planets. I mean, basically, I guess that's a simple explanation. I don't know.
The volatiles that Dave is referring to are largely hydrogen and helium, which were our primary atmospheres for the inner planets. But recall, and so all that material got swept out, easily escaped their planets and got swept into the outer solar system as material, as Dave's saying. But remember, the Jupiter, Saturn, Uranus, and Neptune, quite likely have small, at least by their standards, rocky cores.
Right.
Now, how the size of those rocky cores compares to the inner planets, I'm not sure, but strip all the hydrogen and helium and methane and ammonia away, and what you got? I don't know.
Well, but of course, the other part of that is that it's thought that at least Jupiter and Saturn form differently from the other planets. The other planets are formed by planetesimal colliding and coagulating and basically finally, basically being a couple of large chunks that the gravity dominated, and they pulled all the rest of the stuff in, and that's what formed the inner planets. But Jupiter and Saturn may have been formed, and it's still not known, I think, by basically more of a gravitational collapse of the actual material there, rather than lots of particles hitting, the pieces hitting each other. But again, that's
solar systems.
that's fairly, still. I think they're still working that out.
Yeah.
But it does seem like they formed differently. At least Saturn and Jupiter formed differently from the other planets.
Right.
But
So
yeah.
would it be possible to have a solar system that had rocky planets nearer the star, then some gas giant planets, and then a rocky planet beyond that?
Well, we know that the planets sort of have, for one thing, have moved around in their positions in the solar system. So it certainly could be possible that a rocky planet, even if it had to form within the inner part of the solar system, could be kicked out to the outer part of the solar system, I guess. Could one form out there? I don't know. I guess nothing precludes that, but I'm not sure.
Depends on the distance. It depends on the distance, because the density of material that you have to form with decreases as the cube of the distance, I guess, as you go out and out and out. So that is the story of Uranus and Neptune, right? So it is believed, and if you look at if you're to plot planetary densities, you can see that there's a little jump at Uranus and Neptune. They probably formed much closer in, perhaps even inside the orbit of Jupiter. And then there's this grand tack model of solar system evolution, that Saturn and Jupiter migrated toward the sun, and their immense gravity swung Uranus and Neptune out into the outer solar system. And then we see, as we look at exoplanets, we often see these hot Jupiters, right?
Yeah.
These are like gas giants orbiting often inside what would be the orbit of Mercury.
Yeah.
Yes.
So I think solar systems are messy. I think you could probably if you want.
Well, right. And one thing is, it's really not known if a T Tauri stage, which is this, very powerful, basically blow off of wind that clears out an inner solar system, if that's even a necessary part of stellar evolution. It might happen on some stars and not on others, in which case the volatiles would be just as happy to be in the inner part of the solar system as the outer part, right? So I mean, it's the hot Jupiters are strange, and it just certainly intuitively doesn't match our picture of how a solar system would form, but they're there. So
Yeah.
So the T Tauri model of early solar development is not well established.
Well, I don't think. No, what I mean is, I don't think that every single star has to go through that. I don't think. Do we know that? This is way more up your alley, Lou, than mine. But I didn't know that was a necessary.
The reason I'm asking all this is because this is exactly what has been found 116 light years away: a solar system with one rocky planet, two gas giants, and then a rocky planet.
Yeah. Wow. Okay.
Yeah. And I think that's going to be really interesting to study, because that could be a planet that's migrated, because as the early solar system was a bit like a cosmic billiard table with bodies flying everywhere. This is I think it'd be a really interesting system to study, and it may give us some clues as to the evolution of planets in our system, because it is thought that Jupiter and possibly Saturn as well migrated, and it'll be interesting to Barry says, hang on, put this up here. Barry says planets tend to migrate until they achieve some resonance, which is true. But this is not something we know a hell of a lot about our own solar system, because it's trying to solve a crime billions of years after it was committed. So it's very difficult to establish exactly how many
computer models.
Yeah, absolutely.
Right.
Thank God we have computers to run countless simulations and see which
play
one.
Angry Birds on.
Yeah, absolutely. Ian says we just don't know yet. Very true. But I thought that was quite interesting this week that they found this star system with one rocky inner planet, two gas giants, and another rocky planet. And I think, if I remember rightly, the rocky planets are about the same size as well. So that makes it even.
You wouldn't happen to recall, Andy, what type of star they're orbiting, would you?
Give me 1 second, and I will tell you.
That could be interesting. I mean,
Yeah,
there are differences between massive stars and low mass stars.
that's true. That's true.
Yes.
Let me just have a look, because I did put some notes here somewhere. Here we are. Right.
Hey, this is turning out to be more fun than I thought. Talk about planets all the whole show. That's great.
Oh,
right,
that's
good point.
interesting. It's the most common type in the Milky Way. It's a red dwarf. Which is,
Yeah, I think I had read that.
Okay,
Yeah.
so they're low mass, but they're also pretty flary. Right?
Yeah, yes.
Mhm.
They're not much good for the prospect of life, that's for sure.
Yeah, in fact, right. They talk about the Goldilocks zone for a red dwarf is so close in that it's right. It's probably
Yeah.
uninhabitable just because of all the
There's
activity.
a lot of nasty radiation about.
Right.
Yeah. If you want to look it up, Lou, the name of the star is LHS 1903. So there we are. All right then. Well, I just thought we'd mention that, but that was quite an interesting discussion. Thank you for your contributions, viewers. And we're going to move on now. Now, Dave, let me just check. Yeah. So, Dave, you're going to tell us about Messier madness. Tell us what that's all about.
Yes. Okay. All right. So this is just an idea I had, and I hope people will have fun with it. But here in the United States, in March, at the end of the college basketball season, after the whole the regular season and the tournaments, and they have a few play-in games, they end up with a bracket, basically just a single elimination bracket of 64 college basketball teams, and they just start playing each other until there's one left standing. And especially the first weekend, they are playing basically, well, you can imagine there's 64 teams. That's 32 games just for the first round. They're playing 16 of those games the first 2 days. And so it's pretty crazy. There's like 4 games going at the same time. And then the next 2 days after that, again, there's a couple games going on at the same time continuously for the next 2 days after that. And so they call it March Madness, because especially at the beginning, it's pretty nutty. But I just thought maybe it would be fun to take 64 out of the 110 Messier objects, line them all up in a bracket, and have everybody vote on them, one group, one pair at a time, until we are down to the very best Messier object. and the idea is right. And so best is absolutely, completely, a superficial kind of subjective term. I'm just picturing this as everyone takes a look. Well, first off, I've tried to put them together so that they're, at least in the beginning rounds at least, there aren't like 2 galaxies that are similar competing against each other, if you look at it that way. I'm trying to, there's a nebula in a galaxy, and then a star cluster, and trying to mix up the objects a little bit, and then and also try to set up the brackets so that sort of maybe the most spectacular objects, and again, this is subjective, this is just my looking at them, are not competing with each other too early, knocking each other out, so that we have the final rounds have the quote unquote best objects. And again, this is all completely subjective, but I'm just picturing it for everybody. Just take a look. I'll put up a pair of objects every week. And actually, I think what I'm going to do is probably put up 2 pairs of objects, at least for the first round, because otherwise the first round alone would take 32 weeks. The whole thing will take basically 63 weeks, because that's how many competitions you'd have to have. And Andy, you'd be like a 10th of the way to the moon by then, right? So but I figured maybe I'll do is have a couple pairs of things for at least the first round or first 2 rounds. In any case, I just put up a couple pictures, pick whichever one you like best. There doesn't have to be any reason. You think it's prettier, you think it's cooler. It was the very first one you ever saw, and you have fond memories of it. It's your Aunt Mabel's favorite Messier object. Whatever reason you want, you pick them. You pick which one you want, and we'll vote. And then at each round, the winner goes on to the next round and competes against the other winning objects until we're down to one object. So again, it's a little silly, but I'm putting it together. Let me share a sample sort of initial bracket that I've sort of started on, and okay, so this is sort of what I'm calling round one bracket. In other words, it would be like that, right? So now you have, and I'll show you pictures: Cetus A, Sagittarius star cloud. Pick which one you like better. The Dumbbell Nebula, Galaxy in Virgo. Pick which one you like better. We'll vote on them, and we'll just work our way down to the final four, and then a final Messier object. Yeah, the only I'll talk about it more when I sort of introduce it more formally next week. But the only thing I'm thinking is we should be looking at these, not the Hubble views of the pillars of creation and saying, oh, this is the Eagle Nebula, it's so spectacular, I'm going to vote for that one. But thinking of it, what would we be seeing, right? With a good telescope, or a really nice. I mean, I would like to use really nice images of these, but not Hubble images, not Webb images, not images that are showing so much detail. It'd be something that you would still be expected to be able to see or photograph on your own to be able to compare them kind of fairly.
So the viewers are basically voting not on the image itself, but the actual object.
Right. I'll put up sample images of each one, but think of okay. Right. Go look at it yourself if you want. I mean, look at it actually for real, or go online and look at other pictures of it, or if you're interested in the history of it and you want to vote based on that, do that as well. Like I said, completely subjective, whatever you like. Pick your favorite Messier object out of each pair, and we'll work our way down. And
I think what Dave is saying is, get your C star out and set it up.
That's right. And gets pictures. In any case, yeah. So I just we'll see. I mean, if it's not fun, people won't vote, and we'll say, okay, well, we'll try to think of the next thing. But it should be pretty simple. All you have to do is look at the pictures and pick one. And I've still got to work out a few of the details, but I'll have it all worked out by next week, and then we'll announce the first couple pairs next week, and we'll vote, and the vote has to be in before the next week's show, and so okay.
Or we can do a live vote. It'd be a lot easier if we just did a live vote.
We could do that, but people might want to go and look. Otherwise, they're just looking at my pictures of it that I've picked, right? They might not have time. I don't mind, but we can talk about that. I mean, we haven't worked out some of the details. So it's called, right, Messier Madness, because I guess for us, this is madness.
Yeah. Well, everything is in the US at the moment, let's be honest. So there we
okay. Well, anyway, thanks.
So Fred says, do we have to pay to vote? I just checked. It's the Stanford men versus Pittsburgh on Stanford campus, Maples Pavilion, February 3rd. A 12-year, is that all? $12? Yeah, wow. That's not bad, is it?
He's got something here.
Yeah. I mean, how much you have to pay to go to a British Premier League football match now? You have to pay over £100, I think, don't you?
So, it's a mega money now.
Yeah.
Especially if you want a season ticket.
Any football
corporate
tell
stuff.
us how much it costs to go to a Premier League football match in the UK now. I've never been to one football match in my life, and that was the England against Wales national teams, the under-15s. That was at Wembley, and I've never been so bored in all my life. But never mind.
Fred's just put up. He said he's checked, and they're the worst seats in the back.
Yeah,
Well,
funny that.
for $12, you'd have to be up in the nosebleed section. Yeah, I'm sure. I'm sure.
Yeah,
But,
you need a telescope to watch them.
Yeah,
But no, this is free. This is free. You can vote.
yes, it's free, viewers.
Right.
So join
right.
us next week when we'll start the Messier madness, and between us come up with everybody's favorite Messier object, which is what it's all about. And I'm sure there will be a few predictions that it's going to be, but I won't say anything. Sure.
Oh, the bookies are already looking into the odds on these things, so yeah.
Oh, right. Okay. All right.
Be on Paddy Power.
Yeah.
Paddy Power.
Yeah. So there we are. Okay, let's move on. We're going to go on now to our regular look at the night sky and the viewers gallery, courtesy of a man known to millions as Mr. Astronomy. He is, of course, Roger Astronomy. So,
yay!
Let
Right.
me just put this up for you, Roger. 1 second.
Thank
There we are.
you.
Okay, so over to Roger.
Okay, so we're working our way through the second half of February now, and let's see what's going on. Right. Okay, so we've currently had a new moon, and as Andy says, it's the start of the Chinese New Year for that, so all's well and good. But you have to see the night sky to be able to find the darn thing. So anyway, so we've got Jupiter over high up in the night sky, over towards the south. We've also got Orion gradually heading towards the southwestern skies, unfortunately, and that's clearing away for the galaxy season constellations of Leo and Virgo coming over through. But let's not plan too far ahead. But we've still got plenty of time to see Orion yet, and we also are currently going to be in March. There's going to be a star count between the outer borders of Betelgeuse, Bellatrix, Safe, and Rigel, and see how many stars you can see in there to get an idea of how bad the light pollution is all around the country. So that's one to look out for. That's done by the CPRE organization, just to see how the light pollution has dwindled and worsened over the last few years. So something to think about.
Indeed.
Okay. But as we can see here, we've also got the they've got an announcement of a planetary parade, but unfortunately, some of those planets won't be actually visible without a telescope, and they are somewhat near to the sun, so they wouldn't be visible anyway. So we've got Venus, Mercury, and Saturn following on down beyond after the sunset there, so that can be all good. But as I did notice announce earlier, we've got the annular solar eclipse, which clashes with the new moon, and that's primarily visible in Antarctica. So there was a brief glimpse of a partial, as Daz said earlier, from the southern tips of Argentina, and so it's not really too well viewed, but be interesting to see if there is any postings of genuine annular solar eclipses from Antarctica. So whether any of the scientific bases have managed to capture any to post, it'll be all well interesting to see. So we've got a little conjunction here between Venus and Mercury. So that happens just after sunset. So have a look out for that. And then we've also got Mercury and Saturn getting up close together. So it's all happening. So just to repeat there. So it's roughly after sunset. So try and see if you can spot anything low on the western horizon to have a chance of that. But be careful with the sun being quite close. So
you've got sun in the UK? Blimey.
Well, allegedly. So
We had
we've
some this
got,
morning.
So we've got a little note here to compare the red planet Mars and the blue-green planet of Uranus. And unfortunately, Mars being now the distance that it is away from us, they're almost of a similar size through a telescope. So not looking too good for that, I'm afraid. Ooh, we're going on a bit here. So we've got the crescent moon graying as the week grows, and we've also got another Pleiades passed by the first quarter moon later on next week. So that could be a good thing to see. And should there be any clear skies, there is a meteor shower which can be from the Alpha Centaurids. So looking southeast after midnight, and it's not very sporadic, anything up to 5 to 10 meteors an hour. So good chance with the possibility of seeing something happening there. If you could see the sun today, this is the activity that would have been seen. There's not too many sunspots across the surface at the moment. All the activity is now passed around the western limb, although there are some quite interesting coronal holes over on the right hand side. So whether there'll be anything coming from that, I don't know.
That's a big
There are
hole.
some well, there's been a lot bigger than that. And
Yeah, true.
there are some interesting prominences on the go as well around. So things aren't too desperately playing on the action of the sun. Okay, so onwards with our Space Oddities gallery. We've got a little gallery this week, a little bit bigger than last week. Not a lot, but we've got one here from Michael. Now he's been having a look at some images here. Scorpius and the southern Milky Way from Chile. That must have been a nice weekend break.
Yes, it was a tour back in 2019 for the total eclipse.
Oh, right.
We had a.
So we've got a
Yeah.
So we've got a picture of over on the left and one on the right, which was showing some of the items that you had photographed.
Yes.
Wow.
Very nice.
So,
taken with
Nice.
taken with my newly acquired Nikon Z7 at the time.
right. Of course, those would have been a bit low for us from the UK for those, really.
Yeah.
So well done, Michael.
Okay.
And we've got a crescent moon image from Lou from his mobile phone.
Oh, lovely.
Oh, nice.
Nice.
Oh,
I was up at
Well
5
done.
a.m. I don't know what I was doing up at 5 a.m., but I walked saw that.
perhaps it was the bathroom. Perhaps the bath. And
Yeah, perhaps.
last-
perhaps.
yeah,
our age,
yeah.
everyone does.
Yeah. So we've got the Monkey Head Nebula from Jerry with his usual setup, and this is what he's managed to achieve.
Oh, nice.
Oh,
Lovely.
it's
Well
looking
done.
at us.
Yes, he is.
Wow.
And that concludes the gallery and what's in the night sky.
Thank you very much, Roger. That's great. Don't forget, if you would like to send your images in to the gallery, then couldn't be simpler. Just attach the image to an email, one image per email, please, and mail it off to gallery@spaceoddities.space. And if you could just give us some background on the equipment you use and exposures and things like that. And don't forget, you do have your own little gallery on the Space Oddities website. Any image you send in, if you're sending one in for the first time, you will have your own gallery on the Space Oddities website to thrill and illuminate your friends and family with. Okay, before we go any further, just a quick... This video is sponsored by Picastro. It's like Instagram for space nerds. thank you to Tom, author of Picastro, for sponsoring Space Oddities. As we were talking about astrophotography, there we are. It's a thriving community on Picastro for anybody interested in astrophotography, where you can upload new images, chat with people, and join groups and all sorts of stuff. So that's Picastro, written by our very own Tom McCrory. Tom would also like me to point out that his Messier planner, which you can find at messierplanner.co.uk, he's added a few more catalogues into it this week, not just the Messier catalogue, including the IC catalogue and a couple of others. So go to messierplanner.co.uk. And you know, we are approaching the season, or coming into the season, for observing Messier objects, and it's the perfect companion for planning your observations, making notes about your observations, and it gives you the weather and a lot of other stuff. Tom has put a great deal of work into that. So messierplanner.co.uk for that. Don't forget, if you would like to sponsor, or at least give us some money, then the obvious thing to do, first and foremost, is to buy us a coffee, because astronomers' lives matter and our caffeine levels do matter very much to us. And you can either scan the QR code or click the link, and that will take you to our Buy Me a Coffee page, where you can help us maintain our caffeine levels. Don't forget as well that the Space Oddities t-shirts are available at the Space Oddities shop, and the t-shirts are £20, including UK postage and packing. You need to start thinking about this for summer, because it's just possible you may get a summer in the UK this year. And if you do, it will probably only last a week. So you want to make sure you're out wearing your t-shirts during that week, and the good quality t-shirts. But if you want to hedge your bets and get something for colder weather, then the Space Oddities hoodies are also available for starting at £40, including, again, UK postage and packing. And if you're outside the UK, please add £10 to the total value of your order. Okay, I'm going to move on now.
And I just read this big study that if you drink caffeinated coffee for a long time, your chances of dementia go down. So the more coffees you buy us, the more coherent our shows are going to be.
Yes, that's right.
Obvious.
Yeah,
That'd be nice for a change.
It's a sort of a built-in quality control, really. The more coffee you buy us, the better our shows will be. So
Is that decaf or normal?
Decaf. I spit on your decaffeinated coffee.
I mean, the thing is, I couldn't remember President Kennedy, so I obviously haven't had enough coffee today.
So there we are. All right. Well, it's that time of the week again. It's that time of the week where we delve into the nether regions of the internet to see the lunacy that is being talked about the universe by people on social media. So welcome again to another thrilling edition of Einstein of the Week here on the Space Oddities. And just give me a moment to get to where I need to be. And come here. Right, okay. So Einstein of the Week this week. Well, the first one up this week is not that one.
It's not that one.
No, that's weird.
That was pretty funny, though.
Yeah, yeah, that is funny. Right.
Hey.
So, Einstein of the Week. So the first one, Nile problems. So here we have a map of Egypt showing the River Nile, and somebody posted this on social media in something completely unrelated, but somebody did have a question about this. And the question is, hey guys, I'm new here. Just wanted to ask that if the Earth is a globe, then why is the River Nile?
Oh boy.
Yeah.
Oh, dear me.
Yeah,
We have to work harder.
yeah, absolutely. Yeah, so that was quite funny, I thought. Moving on, demons again. And this was just a little thing on a science and astronomy page called Science and Astronomy on social media about the annular eclipse that Roger was talking about. Tomorrow marks the year's first eclipse, the Ring of Fire annular solar eclipse. This begins what astronomers call a golden era of eclipses. Yes, because we've got two total solar eclipses in Europe this year. I think we've got a couple of lunar eclipses. Somebody was actually wanting to educate us about eclipses, and they said, for your information, eclipses are actually when they open up the demon portal.
Ooh, that explains a lot.
God. Dark.
Yeah, absolutely. So, okay. And onwards and upwards for this. And this is on the Flat Earth Debate Forum. Yeah, so be prepared. When you know the upward vector exists, the argument for flat Earth is credible, demonstrable. Motion upwards vector creates buoyancy, density, air pressure, friction, magnetism, and static electric, which in turn creates tidal motion, sky rotation, weather patterns.
What?
That's
Yeah.
perfectly clear.
Yeah.
Yeah.
Show me the evidence. Show me the evidence.
Buoyancy, density, air.
Yeah.
Yeah.
Well, there's just so many phrases thrown in there. I mean, something has to be right, right? I mean,
Yeah. It's word salad, isn't it?
just statistically.
But it seems that this person seems to think that a vector is an actual physical thing. Whereas a vector, if I've got this right, it's just a representation of a force, isn't it? A vector.
Well,
I don't even think it's been a car.
The direction and a magnitude, right? That's it.
Yeah. So there we are. Anyway.
Even Ford even brought out a vector.
Yeah. So now you know it's everything that happens in the sky is down to the upward vector.
I just know I'm going to wake up at 3 a.m. and all of a sudden understand what he's saying.
You better drink your coffee, like a lot of coffee. If that happens.
Yeah.
I never moonpick.
And so calling all astrophotographers, this was pointed out by our very own Tom McCrory. There's a similar thing to Picastro, but it's for flat earthers. Astrophotography in the firmament. So it says, I decided to make this page which is dedicated to astrophotography. I've grown tired of various explanations from the mainstream about what we see in the sky. So this page will be kept very simple, probably like the people who join it. And so this is astrophotography for flat earthers. So the best of luck with that. So,
isn't firmament just another word for sky?
Yes, the word firmament just means sky. So just another.
So astrophotography is in the sky.
Yeah. Well, that's right.
Brilliant.
Well done.
In the sky, as opposed to in your local library or in your living room. So
I like that they've also noted that it's not a space agency, in case you thought this was.
Yeah. Oh, yeah. I didn't see that. Yes, not a space agency.
Yeah. So just in case.
Yeah, because we all know space agencies, all 74 of them in the world, are complete liars, of course. So there we are. Okay. Airships. Another thing that flat earthers have got a collective B in their bonnet about is airships, and they think they are anti-gravity devices. And this person knows a lot about airships. It says, I never run out of knowledge. So here's this person's knowledge. The blimp is an anti-gravity device. It actually never has to touch the ground at any time. Commercial travel would be practically free, and the airplane scam couldn't make money. The jet fuel hoax is big business. The loss of airplane does significant damage to free Masonic world order. People will build their own. People will see the flat earth. Here it comes, Dave. Obviously, planes are curved, and you can't use your cell phones on a lot of planes to hide the flat earth. And
that's why they do it.
Yeah, that's why, to hide the flat earth. And because these blimps can go higher than airplanes, it's possible to touch the dome with them. This fictitious dome.
Follower of Ptolemy, no doubt.
Yeah.
Well, he never runs out of knowledge.
No, never runs out of
knowledge. If I don't use my car, I never run out of gas, and so I suppose it's the same thing about using knowledge.
So the jet fuel is a hoax. well, what are you actually going to put into these blimps? Because they've got to be either hydrogen or helium. And also anti-gravity device. Okay, then fair enough. So a plane's an anti-gravity device as well. Commercial travel will be free. No, it won't. As regards to flat Earth, I'll skip over that. And also, if the blimps can go higher than aeroplanes, it's impossible to touch the dome. It's with them. Well, unfortunately, if you go higher than a plane, I think the passengers will have a bit of a problem breathing. So it's that's just total nonsense. But there you go.
Absolutely.
I'll think about it when I'm on a plane next week.
Yeah. So this next one, pressure in a vacuum. This was talking about. It was quite a reasonable study, if you like, of what would happen if you were in space in a vacuum without a spacesuit, and apparently you could survive for a couple of minutes. You wouldn't be very well, but you could survive. But somebody took issue with that and said completely wrong. You would be crushed with pressure, whether
you're human or not.
You're human or not.
No, perhaps a little grammar.
Yeah, a little bit.
Would help.
I just wonder if this person has been in space and it's given them brain damage. So
there's ultra pressure then in space, then, is it?
Yeah, that's right.
Something like that.
Well,
yeah,
right.
Just negative pressure. You just put a negative sign. That's all.
Crushed with negative pressure.
There we are. And I think this is the last one. Run that by me again. There is up and there is down. Down is not a force, it's the direction, the original state of creation. There is density and there is buoyancy. Everything we witness can easily be explained with a basic understanding of these fundamentals. There is no such thing as gravity. It's a theory that was designed to make your mind disbelieve reality.
Yeah.
Oh, that's it.
Right. There is.
Yeah.
Oh, it's gone. It's gone.
So
there is down. Down is not a force. It is a direction.
Okay, that's true.
Yeah, so's up and east and west.
Okay.
Yeah.
Public interest message. Do not read these under the influence of drugs.
I think it was written under the influence.
Maybe you'll understand it then. I don't know.
I mean, get a grip, lads. It's the basic fundamentals. Come on, it says there. So, there is no such thing as gravity.
Yeah.
Okay.
No, there's no such thing as
no
gravity.
such thing as gravity. Yeah,
that's true. That's true. It's not a thing. A thing. Oh yeah, I didn't even notice the fig. Yeah,
no, a thing.
Yeah. So there we are. Now you know. There's no gravity. There's just up and down and density and buoyancy.
And this is from an all-star contributor. So you really
absolutely. Okay.
Wow.
This one, the moon is moving away, affecting the tides failing, that it's the Russians or a sneaky second, the Chinese fault. So now you know that it's the Russians or the Chinese are responsible for the moon moving away from the Earth.
Right.
Well, as long as we're blaming somebody else rather than me, I don't care. Yeah, it's the Russians.
It's always the Russians and the Chinese, for God's sake.
Absolutely.
It's moving that moon around all the time.
Yeah, I know.
What are you going to do?
It won't be long before there'll be no surf. You won't be able to surf, would you? No surf.
That's right.
No,
that's right.
Well, that's why it's an annular eclipse, right? I mean, the moon has moved away now; it can't cover the sun anymore.
Now that is, the moon is moving away.
I know that. I know. I know.
Someday, right? Someday.
There's always one.
Well, it's moving away. What? Yeah. What?
3 centimeters a year.
3 centimeters a year, right? Something like that. 3.8 centimeters a year. Yeah.
Yeah. It's about how much your fingernails would grow in a year, basically.
Right.
Yeah. So
speak for yourself. I know.
So there we are. And lastly, this is hilarious. So two pictures for you. First one is light shining through a hole in the darkness. And if you flip that 90 degrees, it's actually a picture of light coming through a hole in a roof and illuminating a spot on the ground below. But the next picture posted by the same person next to it is light shining through a hole in the firmament.
That's what they are.
Whoa.
That's what comets are, you see?
Okay.
You thought they were just dirty snowballs, didn't you? Be honest. Yeah.
All we need is a puncher kit then, just to fit a patch on.
Yeah.
And all those, and all those.
Hey,
fake
invite that
missions
guy on
that
the
went
show.
and took pictures.
He's brilliant.
Invite the guy on the show. Yeah.
So now we know. There we are. And also, just one more. This is what Roger was talking about, the planetary conjunction that's coming up. And there are, well, I lost count of the number of so-called astronomy and space pages on Facebook that are peddling the same nonsense. Because this one says seven planets will align across the ecliptic, forming a silent procession above the Earth. Mercury, Venus, Jupiter, Saturn, Uranus, Neptune, each glowing in quiet harmony, like cosmic notes in a universal symphony. But the next bit is the killer. No telescope needed. Just look up and witness the solar system in motion, peaceful, perfect, and real, and lay off the weed. So, be at one with the universe. No, as you all know, viewers, Uranus and Neptune are telescopic objects only, although there have been people who've claimed due to their exceptional eyesight they can see Uranus without the aid of a telescope. But for the rest of us mere mortals, it's impossible to see Uranus or Neptune without the aid of a telescope. Or I suppose you can see Uranus with a good pair of binoculars, I guess. Anybody know? I would think you probably
don't know.
Yeah, you probably could.
Like,
Anyway, this is nonsense. And as I said, there are so many pages saying exactly the same thing. They're also saying that the annular eclipse in Antarctica will be viewed by billions of people. Yeah, that's another one I read today. That was on a so-called astronomy and science page in Facebook. You see, the problem is that anybody can set up a page on social media without any knowledge or expertise in the subject whatsoever. So you get this all the time, big glaring mistakes like this. And that brings us to the end of Einstein of the Week for this week. So I hope you enjoyed those.
Cheers for that, Andy. Yeah.
They will.
The only people that the only things that enjoyed the eclipse was the penguins. And a few seals. So,
if they live stream it, then billions of people can see it.
Penguins.
Whoever's
They
there,
have the technology.
Well, yeah, because the penguins have to be careful, because if they look up and they fall over, they can't get up again. And in fact, there was a regiment of the British Army who decided to have a bit of a laugh with this during the Falklands War, and they even had a badge made, the penguin erectors of the British Army. And they would tell people that when the helicopters came into land at Port Stanley during the Falklands War, the penguins would look up at the helicopters, fall on their backs and couldn't get up again. And these soldiers had the jobs of going out and standing the penguins up again. And they were therefore the penguin erectors of the British Army, an elite division of the British Army, the penguin erectors. And it was funny. Lots of people actually believed them, of course. I remember reading articles about penguin erectors in British newspapers.
Was it set up on April the 1st?
No, it should have been. but I think the Daily Mail had an article about our brave lads in the Falkland braving the elements to go and stand these penguins up.
You mean the Malvinas?
I mean the Falklands, yes. Yes. Malvinas is
Malvinas. That's what the Argentina's called it.
That's the Argentine name, yeah.
Yeah. And around the time of the Falklands War, I read a long book about the whole history of the Malvinas and who actually has the better claim to the strongest claim to owning. And believe it or not, Argentina has a stronger claim than Britain does to owning them. But we won't get into that.
Well, remember, Andy, it wasn't a war; it was a tiff.
Oh yes, that's right. Yeah, that's right. It was
The worst. It was a conflict.
Fred's got something to say about this. If you trek around Argentina, you will see signs "Los Malvinas son nuestros," aka those islands are ours. Can't they just take you this one and we'll take this one and then let's be friends? It'd be nice if it could work out like that. So there we are. Okay, so that's it. So just to finish off today, we're going to go over to Michael, who's going to give us this week's constellation.
Are we going to Dave for this week in space?
Don't forget poor Dave.
I haven't forgotten poor Dave.
That's all right.
Oh,
I haven't forgotten. No, we'll come to you afterwards, Dave.
That's
Oh,
okay.
okay. You said
That's
you were
fine.
finishing up.
Yeah.
Oh, sorry. Did I say finishing up? I meant
Yes.
now.
Right. Okay. Welcome to this week's constellation of the week, and yet another small one from me. This time it's Scutum, the Shield constellation. So just go through these. There's a picture of the constellation in the night sky with Aquila north of it and Sagittarius to the south of it, and the Milky Way running through it as well. It's just 4 stars that are joined to make the constellation. And I'll go through these now. It's a unique constellation with a historic legacy. It was created in 1684 by Polish astronomer Johannes Hevelius, who mapped it and named it Scutum Sobieskianum, something like that, in honor of King John III Sobieski. I think that's right. The constellation commemorates Sobieski's decisive 1683 victory that turned the tide against the Ottoman siege of Vienna. Unlike other constellations rooted in Greek mythology, Scutum stands alone as the sole constellation honoring a historical figure. Location and visibility. Scutum occupies a primary location in the Milky Way's dense star fields. Its position between Aquila and Sagittarius makes it accessible to observers across most of the globe. August offers the best viewing opportunities when the constellation reaches its highest point in the evening sky at about 9 p.m. Okay, brightest star Alpha Scuti is Ionina. Try and say that. It's an orange giant star of spectral type K23, shining at magnitude 3.85 and located approximately 174 light years away. The star's variable brightness fluctuates by approximately 10%, creating subtle variations visible to careful observers. The Alpha Scuti also radiates 130 times more energy than our sun, a testament to its evolved stellar nature. Once catalogued as one Aquilae, this star was recognized when Scutum became an official constellation. So yet another star that has changed constellations in history. Okay, other prominent stars. Beta Scuti is a yellow bright giant G52 at magnitude 4.22, located roughly 690 light years away. The stellar powerhouse shines with 1,270 times the luminosity of our sun. Delta Scuti is the prototype of an entire class of variable stars at magnitude 4.72. It pulsates every 0.19 days with 2.23 solar masses, creating a cosmic heartbeat. Beta Scuti, a yellow giant shining at magnitude 4.68, part of an astrometric binary system with an orbital period of 6.5 years. Deep sky, two Messier objects. There's the Wild Duck cluster, one of the Milky Way's most spectacular open clusters. M11 contains approximately 2,900 stars packed in a formation, 6,200 light years difference. Also, Messier 26, though smaller than its famous neighbour M26, offers its own rewards. This open cluster is rich in young, hot stars and sits within a previously particularly dense region of the Milky Way. Okay, as giants among giants, red supergiants in Scutum. UY Scuti radius, one of the largest known stars. This red supergiant has a radius over 1,700 times that of our Sun. If placed in the centre of our solar system, it would extend beyond Jupiter's orbit. And Stephenson 2-8 in another enormous red supergiant, Candidating Scutum, may rival UY Scuti in sheer size. Okay. Exoplanets, Corot-17, the only confirmed exoplanet hosting star currently known in Scutum. Corot-17 is a G2V star similar to our own Sun, located approximately 840 light years away. The system highlights the ongoing search for planetary systems beyond our solar neighborhood. This discovery reminds us that a planetary system likely exists throughout this small constellation, waiting to be found. Excuse me. There's also a meteor shower associated with Scutum. It's an annual event peaking around the 27th of June each year. The Scutids, excuse me, gentlemen display producing 2 to 4 meteors per hour. These shooting stars represent ancient material crossing the Earth's orbital path, burning up as they enter our atmosphere. So June Scutids, which you know about. And basically, this Scutum is a shield of history and stars, a constellation that uniquely bends human history with cosmic wonders. Okay, and that's it.
Fantastic. Thank you very much, Michael. And that's this week's Constellation of the Week. And I guess it's better for next week. And
yeah.
We'll almost certainly be doing a much larger constellation. So
excuse my throat. Sorry about that.
Yeah, you've got a frog in your throat.
Yes.
Yes, absolutely. Okay, well, we are going to finish now with Dave. And Dave's going to be telling us all about the week in. So let's just put this up on the screen for you, Dave.
Okay, yeah, I'll get it. Let's see. Who I can share?
Oh, it was there.
Okay.
What have you done with it?
Oh, did I? All right. Well, I'll put mine up. I think I made a couple changes since I uploaded it.
Oh,
so
okay.
If I can
there
share
you go.
mine, there it is. Okay. So yeah. So this was just like I guess this week for your quote unquote Einsteins. This was a pretty good week for history. And what I'm going to have to do, okay, is yeah. Okay. Well, first off, a couple famous birthdays, and I don't need to tell you much about either Copernicus or Galileo, but they were born on February 19th, 1473, and then Galileo born, I think, about 30 years after Copernicus passed away on February 15th, 1564. Yeah, now this is an interesting day, and I imagine that a lot of you remember this, but February 15th, 2013, both the large asteroid that exploded over Chelyabinsk in Russia and the asteroid that flew within 27,000 kilometers of the Earth on the same day, and completely unrelated to each other.
Wow.
Which to me maybe was the most surprising thing at the time, because I had heard, we knew this asteroid was going to be flying within 27,000 kilometers of the Earth, and then we heard about this bolide exploding in the atmosphere over Chelyabinsk. I said, oh my gosh, I guess it's it's a piece of that asteroid that has to come into the Earth. Nope, they're going in completely opposite directions. The DA-14, or now known as Duende, I guess, if I'm pronouncing it right. That was going from down from north to south, and basically the trajectory of the Chelyabinsk was south and north. They could not possibly have anything to do with each other. Just coincidentally on the same day. And like I said, you probably remember the Chelyabinsk. There were dash cams, which is what one of those pictures is showing. There were a lot of pictures of it when it came through, and when it exploded and windows broke. And those 1,200 people who were injured, most of them were injured by glass shattering. Yeah. But anyway, it does give you. It gives you some pause, and of course that was a 10 million kilogram object. This Duende, which came, 27,000 kilometers of Earth, which is very close, very, very close by astronomical standards. That was about 130 million kilograms, and so sort of the juxtaposition would give you the idea of what might have happened if that thing had come into the Earth's atmosphere. The same way the Chelyabinsk one did. But anyway, it was quite a day. I just still remember that.
They did manage to retrieve quite a sizable chunk of the Chelyabinsk bolide from a lake.
Yes, something. A few thousand kilograms, maybe.
Yeah, because when they brought it up, it broke in two, didn't it?
That's right.
Big chunk. Yeah.
And for British viewers, the size of it was about the size of a double-decker bus. The original size as it was entering the atmosphere is about the size of a double-decker bus or 2.5 giraffes.
So okay. Anyway, like I said, I certainly remember that, and I imagine a lot of you do.
Yeah, I can't believe it's 13 years ago. It's outrageous.
I know. There we go again, right?
Yeah.
I thought that happened. A couple of years ago, but no. February 16th. 1961. This is the first orbital launch from Wallops Space Flight Center, which is the basically attached to Goddard, where I worked. But that was where they don't do launches from Goddard Space Flight Center, but they do a lot of launches from Wallops. But this was the first one into orbit. It was Explorer 9. It was basically a giant balloon with a huge reflective surface, as you can see in the picture there, and they sent that up on what was the first satellite to be put into orbit by a solid fuel booster, and they tracked it. They put it in orbit, and they basically tracked it to study the upper atmosphere, really, just orbital dynamics and what would happen to a lightweight object in what was not quite a vacuum, because the upper atmosphere just tenuously sort of disappears as you get out in space. And so at that point in its orbit, which I don't now remember exactly how high it was, but in any case, they could measure atmospheric drag just by tracking this very carefully with these what they call Baker-Nunn cameras, and they had a whole system of these cameras just all over the Earth, and they would just keep a very careful track of the trajectory. Okay, today, so what do we got? 28 years ago today, Voyager 1 passed Pioneer 10 as the most distance from the sun human-made object. Yep, there you go. Oh. And that was only in 1998. Of course, Voyager 1's still shooting out there. But at a distance of 69.4 AU, 10.3 billion kilometers. It took 21 years for Voyager 1 to reach the point where it surpassed Pioneer's. Or for Andy, 244,000 years of walking.
I'll have to check that, you realize.
Yeah, I did. It was a rough back of the envelope calculation there, but it's probably pretty close. Anyway, but again, yeah, now, we're continuing out, and I don't, What did Alan Stern said that New Horizons will never catch up to Voyager 1? Is that what he said, or is that not right? I think he's mentioned something about that, but I don't remember.
I don't
In
remember
any
which
case.
direction it's going.
Well,
Probably
I
like-
mean, just in distance. I mean, obviously they're not.
Yeah,
It's not
yeah.
like it's not like Voyager 1 saw it go by in its rearview mirror. But they're in completely different parts of the solar system, completely different directions. But
he certainly took his own sweet time getting out to Pluto. I'll say that.
yeah, well,
Lou, while we're on the subject, it's a great shame that the Pioneers didn't last as long as the Voyagers. Do you know why that was? Was it just inferior radio transmitters, or why they didn't last as long as the Voyagers?
I don't
In
know.
terms
I
of communicating, obviously they're still out there, but we lost contact with them really early.
Well, they used a similar power source. I think they both had RTGs, and so it's probably plutonium-238 for both of them.
Mm.
So then it would just be a matter of how much and the efficiency of the thermocouples and what they're using it for, how much draw they had. So I don't know. Dave, do you know?
Yeah, I don't. I mean, it was the Pioneers, of course, were older. The Voyagers were built a little bit later. They were launched in Voyager in '77.
Uh-huh.
Pioneer 10. I don't know when it was launched. I mean, it wasn't that much earlier, though, right? It was early '70s. But who knows? Maybe the technology was a little better. Maybe they weren't planning. I mean, certainly, Pioneer 10 was supposed to go to Jupiter and Saturn, and then basically be done. Voyager, they wanted it to go Uranus and Neptune as well, right?
True.
So maybe they had
it.
They may have over-designed it or designed it, so at least it would be working still really well by the time it got to Neptune. And Pioneer 10, they weren't worried about that problem. So that's possible as well. I don't know. It'd be something you could find out, actually, or we could find out. But
something that just occurred to me, could it have anything to do with the Deep Space Network? Because the Deep Space Network had to have its antennas enlarged to receive the signals from Voyager. So could it be that the DSN just lost contact?
Oh, and then before they built the new... that's possible. I don't know the timing, I guess. I really don't. When did Pioneer... when did we lose contact with Pioneer 10? And I know I've got that somewhere too, but I'm not gonna find it right now while everyone's sitting around. Well, anyways, yeah. There's a few reasons that make sense. So I guess we could look into it. But
yeah. As far as the Voyager and New Horizons question, the Voyager one is roughly running at 17 to 18 kilometers per second, and the New Horizons is roughly 14.5 kilometers per second. So no, it will never catch up.
Never catch up, right? I thought Alan mentioned.
And we lost contact with Pioneer 10 in January 2003. Pioneer 11 in November 1995. So,
okay.
So, yeah, just an interesting thought.
Yeah. Well, please look into that. Okay. All right. Well, it seems like every week there's a Pluto reference, but this was actually February 18th, 1930. So, 96 years ago was when Clyde Tombaugh discovered Pluto in the images that he had taken a few weeks earlier at Lowell Observatory. And of course, we've talked about this a lot over the last few weeks, so I'll just move on. Okay, again, harkening back, I guess, to what Lou was talking about with President Kennedy's speech and the early 1960s. This was the first American to orbit the Earth, John Glenn, in Friendship 7. It really did catch the imagination, I think, of the United States even more than Alan Shepard's launch. Somehow, the idea of actually going into orbit. And maybe the other thing was John Glenn was just quite this all-American boy kind of personality, and I wonder if that had had a lot to do with it. But of course, this was the beginning of the United States sort of human space age, I guess, presence in space.
Mm.
Okay, and for Europe, February 21st, 1931, Johannes Winkler launched the first liquid-fueled rocket. Okay, so it's the follow-up to Robert Goddard, basically, in Dessau, Germany. It only went about 3 meters high, but it was, the first true rocket liquid-fueled launch. They had actually launched a little bit earlier, a few years earlier, these they looked like rocket planes. They had wings, and they used rockets, and they were able to sort of fly up in the air. But I guess this was pretty much considered to be the first kind of rocket missile type thing that was launched. And Winkler had founded the German Rocket Society, and he went on to design a lot of different rocket types, and was considered one of the fathers of rocketry in Germany, leading to our next thing, also on February 21st, but now 15 years later, 1946, which was when Wernher von Braun and the Pienemoon team arrived at White Sands, New Mexico in the United States. They had already, the U.S. Army had already gotten to Pienemoon and taken train loads, literally, of documents and pieces and pieces of the German V2s and brought them back to White Sands. And now they needed the scientists from Germany to help figure out how to put them together again and how to launch them. And of course, the scientists in Germany were very happy to turn themselves over to the United States before the Soviet Union got to them. And of course, this was the space race. Basically, was a race between the they would joke about it, between the German scientists and engineers in America and the German scientists and engineers that were in the Soviet Union. And I think there was some joke about that the U.S. got the better German scientists, but for whatever reason, the Soviet Union, still sort of started out ahead. But they did launch an awful lot of the V2 rockets in White Sands, lots and lots of test launches and some of the highest launches. But again, kind of interesting, only 31 years after the launch of the very first liquid fuel rocket in Europe, in Germany, there's this team of rocket scientists and engineers being shipped over to the United States to help kickstart the United States rocket program.
Yeah.
And for the Soviet Union, February 21st was a good day and a bad day. The first attempt at launching the Soviet N1, which was basically the Soviet equivalent of the Saturn V and the rocket that was supposedly going to get Soviet cosmonauts to the moon, it ended in failure. Some metal particles got into the gas turbines. It caused them to start oscillating wildly. It led to a fuel leak. It led to a fire, and it led to the range safety officer destroying the N1 only 69 seconds after it launched. They never were successful with an N1 launch, but it was a monster of a rocket, and I think they just didn't have. They didn't have the ability, and Korolev had passed away, and he was the sort of the
That's right, yeah,
grandfather or the father, of the whole Soviet rocketry program. He basically kept everyone in line. After he passed away, all the different bureaus were competing with each other and weren't, I think, sharing knowledge, and so these kind of things started happening. And the N1 was probably the worst case of this. So that didn't. However, on 3 years later, on February 21st, the Lunar 20 sample return mission touched down on the moon and actually picked up a sample, stuck it into a sample container compartment in a little tiny rocket, shot it back to the Earth, and they picked up the sample in Siberia in the winter. And so it was the second robotic sample return ever done from the moon, so that was a big deal for the Soviet Union, because at that time they were, after having lost the moon race, I guess, not getting the first people on the moon, they were big on arguing that there was no reason to send people anyway. They had these robotic things, and they could get samples back. And why would they have bothered sending astronauts anyway? It was a waste of time, maybe. So, and I believe
They're borscht.
it's just sort of, the whole sour grapes thing, maybe or maybe not. They did. I mean, they did have some amazing, the Lunar hods and the sample return missions. I mean, they did have some pretty amazing robotic missions.
Oh, the Lunar cods were amazing.
Yes. So in the in the early 70s, they really did. The robotic lunar program was the most advanced in the world, and I'd say up until the until the Chinese missions now, it's up. It was the most advanced up until just a few years ago, really. And I believe that's it. Yes, it is. Okay. So
Nice. Thank you, Dave. Thank you very much
Thanks.
indeed. So well, quite a busy commemorative week there.
yeah.
Some great things that happened there. And
Yeah, of course. I mean, you've got to look at the German scientists' point of view as to whether to go to America or Russia. I mean, America was offering them the land of the free and all the opportunities, and Russia were just offering them 2 goats. So I think this is a bit obvious.
a bunch of old tractors and vacuum cleaners to make their vehicles out of. And of course, the operation to snatch the German scientists before the Russians did was Operation Paperclip.
Yes.
Right,
Right.
Yeah.
And there literally were train loads of documentation. They managed to save all that and ship that back to the United States before the Soviet Union got to Pianamon. So it was quite an operation, apparently.
And viewers, if you would like to learn more about the life and career of Wernher von Braun in building the V2 and then his work in America constructing eventually the Saturn V, there's a video that we made on the Space Oddities channel all about the life of Wernher von Braun. So there we are. Well, that brings us to the end for this evening. But big thanks to Lou and to Dave and to Daz and to Roger and Michael. Thank you guys again. We will be back this time, well, not this time, at 8 o'clock next Tuesday, as always, on Space Oddities. And keep your eye on the channel so you can see what's going on. Don't forget to subscribe, and that allows you to turn on the notification bell. So if you forget to watch us, you'll get a notification telling you when we're going live. And we'll be posting some more videos on the channel this week as well. So keep your eye on the channel. So until next week, we'd like to thank you all so much for being here, and wish you a fantastic week. Hope the weather in the UK picks up for everybody. You can get out and take some more photos for the gallery. That's what it's all about, really. Nothing else matters. And so have a great week, everybody. Take care of each other, and we'll see you back here on Tuesday on Space Oddities. Bye-bye.